So far in our introduction to Python, we've been mostly looking at singular data values, things like the string Python or just the number 3.14. But as you know, in data analysis, typically we have larger data structures, larger data collections. In this lesson, we're going to look at the building blocks for creating these data structures in Python. We're going to look at lists, we're going to look at dictionaries, series, and finally, data frames. So let's get started. As usual, we're going to start by opening a new Colab notebook. I have mine open there, and I'm going to call this one data_structures. So here is our list of learning objectives. If you want, you can pause the video and read through these, but we're going to come back to them at the end of the lesson. For now, let's create a new text section and call it imports. And beneath that, in a code section, let's import the library that we need. And for this, we only need one library. It's called Pandas, and it's the library that manages data frames in Python. So let's type import pandas. And generally, in the Python ecosystem, people use the alias PD for pandas. So import pandas as PD. And let's run that. And I'm going to go ahead and hide the top section of my Google Colab notebook here, so I have a bit more real estate. Now I'll open a new text section and call it Python lists. This is the first data structure we're going to look at. And so I'm going to give a very colloquial definition of a list. A list is like an ordered container, okay, that can hold different types of information, different types of info. Let's make a very simple example shopping list. So I'm going to type shopping equals, and the syntax to create a list is a square bracket. So square bracket, open and close. And inside of here, we're going to put the elements of our list. Let's put a number of shopping items, maybe apples, bananas, and cherries. And on a new line, I type shopping so I can display the value of this list. And as you can see, we have a nicely created list of apples, bananas, and cherries. Now let's see how we can work with this list. One thing you may want to do with the list is access the elements of that list. And this is very simple. We're going to type shopping and then open and close square brackets. And if we want to access the first element of this list, we're actually going to put in the number 0 because Python uses what's called zero-based indexing. That means this first item here has an index of 0, this one has an index of 1, and an index of 2, and so on. Sometimes I like to think of it as having a pointer here at the bottom left of each of these words. And so this is position 0 here. This is position 1. This is position 2. And position 0 corresponds with the first item. Position 1 corresponds with the second item, and so on. Anyways, if we run this code now, we're going to extract apples, which is our first item. If we do shopping 1, we access bananas, and so on and so forth. If you want to replace this item in the list, you could also use a similar subsetting syntax, this square bracket syntax. So all we're going to do is we're going to type, let's do it in a new code chunk. We're going to type shopping 1. So here we're replacing the second item, bananas. And we can just simply set that equal to a new fruit, let's say blueberries. And if we press Control or Command Enter to run that, and then we print again our shopping list, you can see now we have apples, blueberries, cherries, so bananas has been replaced. There are many methods that are accessible to lists. For now, I'm only going to look at one example, because generally as a beginner data analyst, you're not going to be doing a lot of work with lists. So we'll give it a very brief coverage. So let's look at one example kind of method for lists, and that is the count method. So if I do shopping and then a period, I can use the count method. And what the count method does, as you see, the help comes up very nicely for us. It returns the number of occurrences of a specific value. So let's say we want to count the number of apples in this list. We can go ahead and do that. Shopping.count apples. And you see it gives us a value of 1. To make sure that this code is actually working, we could maybe change item number 2 here with the index of 1 to also apples. Okay, and now we have apples, apples, cherries. And now if we run shopping.count again, you can see it gives us the value of 2. So now go ahead and try this practice question. So here is some practice for you. I want you to create a list called temps, which stands for temperatures, with the values 1, 2, 3, 4. very nice and simple. Then I want you to print the first element of that list, first element of the list. And I want you to change the last element to 6. So pause the video and try that out. Now let's open a new text section and create a section called Python Dictionaries. And let's give an informal definition or explanation of a dictionary. I'm going to say dictionaries are like labeled storage boxes for data. Storage boxes for data. And each piece of data has a unique key, You can think of that as the label, which helps identify a specific value. Okay? So you're going to have key value pairs in dictionaries. Let's see a brief example. We're going to create a dictionary of grades, and we're going to initiate it using these curly braces here. Hopefully you know where to find these on your keyboard. So curly braces, and let's create 3 example students, and we're going to say that Alice has a grade. So Alice colon 90. Alice has a grade of 90. And let's put spaces here just to follow the convention. Then we put a comma to separate this piece of data from the next one. And we're going to say the next student, Bob, is not as good, and he has a grade of 85. And the final student, Charlie, is the worst of the bunch, and he has a grade of, let's say, 70. So notice that because these are strings, they go in quotes, but this is a number, so it can stay outside of quotes, right? Now let's run this to define our grades object. And we can also print it out to display it on the screen. So there we have our nice dictionary. Now, in order to access the elements of this dictionary, let's see what syntax we're going to need. So remember, for the list, we did something like this, maybe grades and then square brackets, element number 1, which has an index of 0. If you try to run this, you see it doesn't work. So in order to access the elements here, we're going to use the keys. All right, so we're going to say, for example, grades, Alice, and this lets us access Alice's grade of 90. Or you could try grades of Bob, and we get Bob's grade of 85. And we can modify existing values using a similar syntax. So let's change Charlie's grade, maybe. Grades for Charlie. Let's change it to 75. Maybe there was a mistake. And let's print that just so we can make sure it works. So now you see Charlie's grade has been changed to 75. Now finally, we can add a new element to this dictionary using similar syntax here. So let's add a 4th person. Let's give them a name starting with D, just to follow our trend. So we're going to say the grades for, let's say, Donald. All right, and let's say he got a score of 50. And if we run this, we have now added an element to grades for Donald. Let's print it out so we can see the output. So there's our 4th element there, Donald with 50. So that's a very brief introduction to dictionaries. Again, we stay very surface level since these are not the primary data structures you'll be working with as a Python beginner data analyst. So we stay very surface level. Let me give you a practice question. I want you to create a dictionary called prices, with the following key value pairs, I want an apple to have a price of 0.5. I want a banana to have a price of 0.25, and I want an orange to have a price of 0.75. Okay. Then I want you to print the price of an orange using the key. I want you to add a new fruit, a new fruit called grape, with the price of 1.5. And I want you to change the price of a banana to 0.3. So that's lots of questions. Pause the video and try those out. So the next thing we're going to look at are series, and series come actually from the Pandas library. So they're not built directly into Python. They come from this external library Pandas, which we imported at the start of our script. Let's open a new section and call it series, or maybe Pandas Series. And we can give a brief description of Pandas Series. We're going to say series are similar to lists, but with additional features useful for data analysis. And we open a new code section and let's define our first series. So I'm going to define an example series called temps for temperatures. And in order to create a series, what we're going to do is we use the pd.series function. Remember, PD is the alias for pandas that we imported all the way at the top here. So make sure you ran that piece of code. And that gives us access to the pandas library under the alias PD, which gives us access to the series function. And with the series function, we can convert what looks like a list into a series. So let's just make a very simple series with 4 numbers, 1, 2, 3, 4. And let's go ahead and print the value of that series. As you can see, this output is starting to look more like the kinds of things you would see as a data analyst. So it looks kind of like a column of data, and it seems to have an index over here, 0, 1, 2, 3. Now let's look at some interesting properties of series, or some interesting methods of series. One thing we can do with a series is we can easily calculate summary statistics. So we can grab our temps and do a period, and we have access to a number of methods here. Let's try temps.mean. That gives us the mean of these numbers 1, 2, 3, 4, which is 2.5, as you can see. We can also do temps.median. Let's see that. That is also 2.5. And since we have multiple outputs in a single code chunk, let's add print statements. So print here and print there. Okay. And let's do a final one where we calculate the standard deviation. So temps.std, open, close our parentheses. We run that and we see all of our outputs there. Now, a nice thing about series is that they can have a custom index for intuitive access, similar to the keys in dictionaries. What do I mean by that? Let's go ahead and define a new temps series, and we're going to give it a custom index. At the moment, the default index is 0, 1, 2, 3, but we're going to change it. So let's copy all of this code so we can save some typing time. And I go down and make a new code section. And maybe we can add a comment here to explain what we're doing. Here we're going to add a custom index. Now, in order to add a custom index here to this series, I'm going to put a comma after the definition of the list. And I'm going to say index equals, and I open up another list, and we're going to give 4 elements since we have 4 elements here. Let's imagine these are days of the week. So Monday, comma, Tuesday, comma, Wednesday, and finally Thursday. And instead of calling this temps again and overwriting our other version, let's call this temps label, and we'll copy that and paste it there. So let's go ahead and run this and see what it gives us. And as you can see very nicely now, we have Monday, Tuesday, Wednesday, Thursday as the indices for these values inside of the series. And we can access those values using these indices. So let's see how to do that. We're going to type temps label. And similar to the list, we're going to open up our square brackets and type maybe Monday. And that gives us the value of 1, Tuesday, the value of 2, and so on. We can still access it with the numerical indices. So remember that Tuesday now is going to have the index of 1. So if you want to access it that way, you can also do that. Okay, but now that I ran this, I see that there is actually a future warning that's saying that treating keys as positions is deprecated, and in a future version, it will no longer work. Interesting. So don't do that. If you already have labels there, then you should use only the labels. So let's put Tuesday back there. And we have that. Here's another practice section for you. Okay, I'm going to call it practice. And I notice I've been using double hashtags for the practice questions. You may be wondering whether to use single or double hashtag for your code comments. It doesn't really matter. Sometimes I prefer the double hashtags because they look somewhat neater, but you could have as many hashtags as you want or as few hashtags as you want, up to just 1. It has to be at least 1 hashtag. Okay, let's do our practice question. I want you to create a series called rainfall, or let's call it rain, with the values 5, 4, 3, 2, 5, 4, 3, 2. And I want you to get the mean and median rainfall for those 4 values. So pause the video and try that out. Now for our final section, which is what you all came here for, let's look at data frames, which also come from pandas. So we're going to make a new section and call it pandas data frames. So this is a new text section. And I'm putting in markdown pandas data frames. Usually we have the D and the F capitalized in the word data frames for pandas. And let's go ahead and write that pandas are like series, but in 2 dimensions. And we can say most important structure for data analysis. Most of the time as a data analyst, you are going to be importing external data frames, of course, but it's useful to know how to create these data frames from scratch anyways within Python. So let's see how to do this. I'm going to open it up a new code section, and I'm first going to create 3 lists. You could also create 3 series, but lists suffice for this. And I'm going to call the first one names equals, and let's give our 3 names, Alice, Bob, and Charlie. Alice, Bob, and finally Charlie. And let's capitalize that B just so it matches the others. And let's add ages equals, let's do 3 ages, 25, 30, and maybe 45. And let's create a cities list as well with 3 cities, Lagos, maybe London, and then let's say Lima in Peru. So we have these 3 lists and we'd like to structure them into something that looks like a table, which is a pandas data frame. How do we do this? First of all, let's run this section and let's do the next part in a new code section. We don't have to do it in a new code section, but I'm doing it that way anyways. So let's call this data, create an object called data, and data is going to be a dictionary, okay? And the keys for this dictionary are going to become our column names. So the first key is going to be called name, colon, and we provide this names list here, names, and we put a comma, and then the next one we'll call age, colon, and let's provide the ages list. And finally, let's do a last column name, and let's give that the value of cities. So now this is a dictionary with these 3 key value pairs. Let's print that dictionary just to see what it looks like. All right, so we can see the structure of our dictionary. And as a final step now, we're going to pass this dictionary into a pandas data frame function. So let's do that. Let's create an object called people.df, and set that equal to pd. Remember, pd is our alias for pandas, dot data frame. Notice the capital D and capital F. And then we give it our data object, and this will create a data frame. Let's print out the value of the data frame by copying and pasting people.df with Control-C and Control-V. And let's run this. And finally, now we have a data frame. And very nicely, Google gets excited because it recognizes this data structure and it says, hey, do you want to view the recommended plots for your data frame? Why not? Let's see the recommended plots for our data frame. These are not very informative plots since this is not a very large data frame. Let's go ahead and close this. So we've created this data frame in sort of very distinct steps, but you can combine all of them into a single call. Let me show you what I mean. So what we could do is we could just grab the pd.dataframe function here. And instead of pre-creating data and pre-creating each of these lists, what we can do is, let's see, what's the best way to do this? I'm going to copy this dictionary definition here, and I'll put it inside of my pd.dataframe function. And let me press tab a few times so it becomes a bit neater. And instead of predefining names, you could have just provided the list of names directly into this dictionary and directly into the pd.dataframe function. So let's do that for ages and for cities. And if I'm moving too fast, of course, you can pause the video and catch up, or you could play the video at a slower rate. Okay, so now I've done all the same things I did in the stepwise fashion, but all in one code chunk. Let's define this again and call it maybe people df2 to differentiate it from the first one. I set that equal, and on a new line, let's print people df. And if we run this, we'll see that we have the same output. Okay, now let's look at a few things we can do. So now we have a pandas data frame. Congratulations. Let's look at a few things we can do with a pandas data frame. Now, future sections of our course are going to focus very deeply on how to work with, how to manipulate, how to slice data frames. Here, we're just going to give a very brief introduction into the kinds of things you can do with data frames. To start with, you can extract specific methods from your data frame. I'm going to type people df to access my data frame, and then period to access the specific methods. And let's use a very simple method, which is called describe. And if we run this, we will describe the data frame. And what this does is it gives you a description of the numerical columns in the data frame. For now, only the age column is numerical. Let's try another one, which is .info. And that will give you, let's see what it gives us. This gives us some other information. It gives us the column names, the data types of each of those column names, how much memory the object is using in our computer, and so on and so forth. Those are some very simple methods. We can also access, of course, the individual columns of the data frame. Let's see how to do that. I'm going to open a new code section, and I'm going to type people df, and let's access the city column. I'm going to use the square bracket notation, put in the string city inside the square brackets, and that way we subset to just that column. Let's open a new code section and subset to a specific row. To subset to a specific row, we're going to type people underscore df, and then we're going to use what's called the look property. And let's say we wanted to get maybe the second row, which has an index of 1. We're going to type .look and then use square brackets and set that to 1. Sorry, not 2, but 1. And that gives us Bob, which, as you remember, is the second person, Bob 30 London. And very nicely, this row is returned as a series, so it comes with those nice labels that we wanted, which means if we wanted to go even deeper now and access Bob's age, we could now append age to this selector. So now I'm going to put another pair of square brackets and type age. And now we can access that specific value. So we're accessing the row first, and then that specific column. We could do it in the other direction. So let's open a new code section, do the same thing, but we first access the age column, and then we'll get the lock operator on that output and access the first or the second value, which has an index of 1. And we see we have the same output there. Finally, you can get summary statistics on specific columns from a data frame. Let's see how we can do this. We're going to type people df, and let's get the mean age. So I'm going to subset to column age. So type this, and then we can access the method .mean. Since this is a series, we can access the mean method. If we run this, we have the mean age here, which kind of makes sense given our values. Yeah, let's make sure that makes sense indeed. And just for good measure, let's also try the median age, and we can see that's 30. Since we have two values here, let's print the both of them and press Control or Command Enter to run the code. So that's a very brief overview of the kinds of things you can do with data frames. Don't panic if much of this hasn't stuck in your head yet. We're going to be working with data frames for much of this course, and you'll get much more familiar with how to manipulate and work with these data structures. For now, go ahead and do this simple practice question. Let's make a new section and call it practice. And I want you to create a data frame called students, and it's going to have three columns. The name, their ages, and their grades. And you can use the values that we set for the initial student dictionary here. Okay, so these are going to be their names and grades, and you can pick their ages. Okay, so let me paste this in. So use these names and grades. So Alice should be 90, Bob should be 85, and Charlie should be 70. And let me get rid of these colons so you don't get confused. And you pick the ages. Now some extra manipulations you should do are to show only the grade column. Okay, so using the subsetting syntax that we've seen above. Then calculate the average age of the students. And finally, display the row for Bob. That's a lot of questions to get your brain flowing and thinking about data frames. Pause the video and try those out. Okay, so that brings us to the end of this exploration of Python data structures. Hopefully now you feel familiar with these learning objectives. You can now create and work with lists and dictionaries. Remember that lists are just collections of ordered information, and dictionaries are those key value pairs that we talked about. Now you understand how to work with series. Remember that series are kind of like fancy lists with specific methods and properties that make them amenable for data analysis. And you also understand a little bit about Pandas data frames, which are similar to the tabular data structures that you are most familiar with. So congrats on getting through this lesson. You now have the basic tools and the basic vocabulary to start working with real data sets in Python. I wish you the best of luck on the journey, and I'll see you in the next video. Bye-bye.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.